Welcome to this explainer. Look, if you're gearing up for your AQA GCSE Maths exams, mastering probability tree diagrams is literally your direct ticket to securing 6 to 8 easy marks on your paper. And the best part? It only takes a few minutes to nail down, so let's jump right in. Here's our roadmap for today's revision session. 1. Independent versus dependent events. 2. Mastering probability tree diagrams. 3. Calculating combined probabilities. 4. Common misconceptions and errors. And finally, 5. Exam tips for maximum marks.
Section 1. Independent versus dependent events. Okay, so before we draw anything, we've got to establish the ground rules. Independent events mean the outcome of one event simply does not affect the next. It's like flipping a coin and then rolling a dice, right? The coin absolutely doesn't care what the dice does. But dependent events? That's where the outcome of one event actually changes the probability of the next. Think about drawing cards from a deck without putting them back. The crucial takeaway here is that while independent events leave your probabilities totally unchanged, dependent events alter the total sample space for that second event. Always ask yourself in an exam, wait, did I put the item back?
Section 2. Mastering probability tree diagrams.
Now, a standard probability tree diagram is basically the ultimate visual tool. It brilliantly maps out every single possible sequence of outcomes. You just read it from left to right. You start with the first experiment, which splits into your outcomes, say A and not A. Then, off those branches, you split it again for the second experiment. It takes what could be a totally messy, confusing word problem and organizes it into a perfectly clear, logical path.
As you're building your tree, you absolutely have to remember this golden rule. The probability of not A equals 1 minus the probability of A. In plain English, the probabilities on each pair of connecting branches must add up to exactly 1. Think of this as your built-in safety check during the exam. If your branches from a single point don't add up to 1, well, stop, pause, and go back because something's off.
To make sure you're scooping up full marks, treat this 4-step method like a totally infallible algorithm. Step 1. Fill your branches with the correct probabilities. Step 2. Identify your required target outcomes right at the ends of those branches. Step 3. Multiply along the paths to find your combined probabilities. And Step 4. Actually use those numbers to answer the specific question they're asking. Easy, right?
Section 3. Calculating combined probabilities. Listen, if you take literally nothing else away from this explainer today, please memorize this rule. And means multiply, or means add. When you're following a single path from left to right, you're basically saying to yourself, this happens and this happens, so you multiply along those branches. But when you have multiple different winning paths, you're saying, well, this path or this path could happen, so you add those separate cases together at the very end.
Let's see these dependent events in action with a classic cricketer example. Our cricketer is facing left and right-handed bowlers. Now, notice how the probabilities in the second innings change based entirely on what just happened in the first innings. If they get a left-handed bowler first, the chance of getting a left-handed bowler in the second innings is 0.52. But if they face a right-handed bowler first, that chance drops all the way down to 0.13. All 4 probabilities in that second stage are completely conditional on the first. It's like a chain reaction.
And this brilliantly illustrates the math in action. Let's say we want to find the probability of getting a left-handed bowler and a left-handed bowler. We just use our multiply along rule. 0.35 times 0.52 gives us exactly 0.182, or an 18.2% chance. See? The actual math is so much easier once the diagram is set up correctly.
Section 4. Common misconceptions and errors.
Let's shift gears for a second and look at where students consistently drop marks. Consider this actual quote from a student explaining their reasoning on a diagnostic test. They literally wrote, because 0.6 divided by 2 games equals 0.30. Wow. Okay, this highlights a massive misconception. They're dividing. The fundamental flaw here isn't just a silly arithmetic mistake, it's a total failure to understand the concept of the tree diagram itself. Remember our golden rule from earlier? We multiply along the branches, we absolutely never divide.
Beyond that, you've got to watch out for these classic exam traps. First, forgetting to subtract from the total for at least 1 questions. Don't worry, we're going to cover a genius shortcut for this in a sec. Second, accidentally replacing an item on the second branch when the question explicitly says without replacement. Always update your denominator. Third, forgetting to add up all the relevant outcome paths. And finally, just making silly arithmetic slips when you're dealing with big denominators like 60 or 120. Stay sharp on those fractions.
Section 5. Exam tips for maximum marks.
All right, to guarantee maximum marks on your AQA GCSE paper, you absolutely need to use the at least one shortcut. If a multi-stage question asks for the probability of at least one, please don't waste time calculating and adding up 3 or 4 different branches. Save your precious exam time by calculating the probability of none happening and then just subtract that from 1. It is a massive, massive time saver.
Here's another massive pro tip. When you're multiplying fractions along the branches, do not simplify them yet. I know, it's super tempting, but keeping common denominators across all your branch ends makes adding your final probabilities together so much easier later on. It really prevents those frustrating arithmetic slips. Only simplify your final answer if the question explicitly asks you to.
Now, there's a big difference between your rough scratch pad and your actual exam paper. Look, it can be really tricky to get a tree diagram looking perfect on the very first try. So don't be afraid to sketch a rough draft first just to map out the sequences and outcomes. But for your final submission, you must draw neatly, label every single branch, and run that built-in check to ensure that your branch pairs add up to 1. The examiner needs to clearly see your logic to award you those full marks. Help them help you. To wrap this all up, I want to leave you with a quick thought. Next time you're making a decision in your own life based on past events, ask yourself, are you calculating independent or dependent probabilities? Take this mathematical mindset into the real world. Keep practicing those tree diagrams, remember to multiply along and add between, and you'll be fully prepared to grab every single probability mark on your AQA GCSE exam. Thanks for joining me on this explainer.